trying to take the derivative of sine inverse of x. So we can let y equal sine inverse of x and then solve for x. So we'd get x equals sine of y. And to find out what sine of y is, well, we know it's opposite over hypotenuse, and we know that it's equal to x, so we can construct a triangle with the angle y and x as the opposite and the hypotenuse as 1, so that way we get x. Because opposite over hypotenuse, so x over 1, so we get x. So this would be the construction of the triangle, and then we can just call this base b, and that's going to help us solve for cosine y, because cosine y is adjacent over hypotenuse. So the adjacent to the y would be b over the hypotenuse 1. So we get that cosine y is equal to b. But that doesn't really help us much, so we can use Pythagoras' theorem, in which says 1 squared is equal to x squared plus b squared. So the hypotenuse squared is equal to the side squared, the sum of the side squared. So we get that 1 squared is equal to x squared plus b squared, and then we can solve for b, and we get this. And of course, you don't have to do this triangle, you can just use the identity, the trigonometric identity. So this is another way to solve for sine of y. So using this identity, we can solve for cosine of y, and we're going to get this. So you can subtract the sine squared and then take the square root, so we get this. So notice we get the same answer here and here. So there's two different ways you can do it. Now we can take the derivative, in this case with respect to y. You can do either one. You can do it with respect to x or y. In this example, I'm doing with respect to y. So we're going to get dx dy is equal to, so we're taking the derivative with respect to y both sides. So we're going to get dx dy is equal to cosine y. But we don't want dx dy, we want dy dx. So we're going to flip it, and we get that dy dx is equal to 1 over the square root of 1 minus x squared, which is the answer. And so that's one way. Like I said, the other way would be to do it with respect to x. So differentiate with respect to x. So the derivative with respect to x, of course, dx over dx is 1. The derivative of here with respect to x, well, we're going to have to use the chain rule, implicit differentiation. So the derivative of sine of y with respect to x, you might think it's 0, but since it's equal to this x, we're going to have to use implicit differentiation. So this is going to be cosine y times the derivative of the inside of the function, so dy dx, because we're doing it with respect to x. So we get this, and then we can solve for dy dx by dividing both sides by cosine y. And again, to solve for cosine y, you can use a triangle, or you can use this identity. So we find out that cosine y is equal to square root of 1 minus x squared. So that's the other way. So again, to solve for cosine y, you're either going to use a triangle or the identity. It's up to you. You don't have to do both. And then, of course, you can differentiate with respect to y, or you can differentiate with respect to x. But in this case, differentiate with respect to x, we had to use implicit differentiation. Another way is to use this rule. So if we have a function of some inverse function, essentially these kind of cancel, and we'll just get the inside, which is x in this case. And if I take the derivative of this, again, we have to use the chain rule. So it's the derivative of the outside times the derivative of the inside. So I'm taking the derivative of both sides with respect to x. So the derivative of x with respect to x is 1. And then I can solve for the inverse derivative, and I get 1 divided by f inverse of, 1 divided by f prime of f inverse of x. And a lot of times we always let this f inverse of x equal y, just how we did over here. So like this is an inverse function. So like this is basically f inverse of x. Okay, so that's what we have here. Y is basically f inverse of x. So this is the rule we're going to follow. So again, we're doing the same thing. We're trying to get the derivative of this. We're saying that y is equal to f inverse of x. This is basically always the case. And of course, to solve for x, we get x equals sine y. Okay, so f of x is equal to sine of x, because of course if sine inverse of x is equal to f inverse of x, then the original, the f of x, is just equal to sine of x. But we don't want sine of x, we want sine of y, because we want to find f prime of y. So just plug in a y. So we know that f of y is equal to sine of y. So that means that f derivative of y, f prime of y, is equal to cosine y. And again, we're back at cosine y, so you can use a triangle or you can use the Pythagoras' theorem. The identity. And so again, we get that cosine y is equal to square root of 1 minus x squared. And of course, the formula says 1 divided by f prime of y. So it's going to be 1 divided by square root of 1 minus x squared. And so basically, these are 3 different ways that you can find the derivative of sine inverse of x.